Hello class, today we're going to look at graphing algebraic expressions. So the standard that we're looking at today, or that we're working on, is we're going to represent linear relationships using verbal descriptions, tables, graphs, and equations that simplify to the form of y is equal to mx plus b. Okay, so on Monday, when we talked about algebraic expressions, okay, we looked at verbal descriptions. We learned how to translate expressions into sentences and sentences into expressions. Okay, we also learned how to evaluate expressions, where I gave you a series of values and gave you multiple expressions to evaluate using those values. All right. Yesterday we looked at tables or T-charts. So that means I gave you an expression and gave you multiple values in order to evaluate that expression for. That was our tables. Today we're looking at graphs. Okay, so today we learn why we put data into a T-chart. So let's begin. Let's take one of the problems that we had on our assignment the other day and let's evaluate it and find out why we put our data in a T-chart. Well, the other day I asked you to take these values for x and just plug them into our expression because our T-chart said something to us. It said if x is -2, then x plus 4 is what? So that's the language of a T-chart. And basically it just asked us a question. So what our job is to figure out what's the answer to that question. So I'm going to take the -2, plug it into the x, and then evaluate. -2 plus 4 gives me 2. Okay, then I move on to the next one because now it says if x is -1. Okay, so I plug in -1 plus 4 and I end up with 3. Then the next one is 0 plus 4 and we end up with 4. Now after 3 of those we can then determine a pattern. Okay, what are we doing from one x value to the next? We're adding 1. Okay, so for our evaluation. So we're adding 1 here and we added 1 here. So that means I'm going to add 1 to get to the next one, to get 5 and then to 6. Well, the reason why we organize our information in a T-chart is because what you have created is a set of coordinates. Okay, where this value is our x part of the coordinate and this value is our y part of the coordinate. Okay, so that's all this is a series of coordinates, and if we graph those coordinates it shows us the picture of what x plus 4 looks like. So let's see if we can do that. Let me draw a graph here. Okay. So here is our graph. Now we need to put some tick marks on it, and I'm going to use the data in our T-chart to determine how many tick marks I need. But you'll notice on my x side, for my x-axis, I have -2 to +2, so that means I need 2 tick marks on the left and 2 tick marks on the right. Okay, for my y side, or the y-axis, I go from +2 to +6. So that means I don't have any negative values, so I don't need to put any tick marks down here in the bottom, and I need 6 tick marks going up. And now we graph our points. So our first coordinate says I'm going to go left 2, up 2 from the origin. So left 2, up 2, put a dot. The next one says I'm going to go left 1, up 3. So from the origin I go left 1, up 3, put a dot. The next coordinate says 0, 4. So I'm going to go right or left none, go up 4. Now what do you notice about those points so far? It kind of looks like they're on a line. Well, let's see if the others fall in that same line. Okay, so the next point is 1, 5. So that means I'm going to go right 1, up 5. And then the next point is right 2, up 6. Right 2, up 6. And sure enough, it does kind of appear that they lie on the same line. But it's not a line yet. Okay, so let's kind of talk about what this represents. All I had in this T-chart were 5 individual points. Okay, so I graph those points. Now it appears that they lie on some sort of a line. So let's talk about that and figure out between 0 and 1. Do you think there could be a point in between that? Yes, and there is. What about 0.5? Or what about 1/10? Or what about 1/100th? Matter of fact, there's an infinite number of points between 0 and 1. There's also an infinite number of points between 1 and 2, and between -1 and 0. So the way we represent that is we connect those dots to represent all those points that could be part of my line. Same thing for between 1 and 2. Between -1 and 0, and between -2 and -1, there's an infinite number of points that represent that. Okay, so we connect the dots. Now there could also be points that continue on in both directions. So the way we represent that is we draw a line through it and we put arrows to represent that those points can continue going in both directions. And this is the unique image of what x plus 4 looks like. No other graph looks exactly like x plus 4. Now there will be some that will look similar, but none will look exactly like that. Okay, so let's look at another one. Okay, here's another problem that we had on our homework assignment. So this one is 2x. Okay, so we would take our 2 and multiply it by negative 2 to get negative 4. Take our 2, multiply it by negative 1 to get negative 2. Take our 2 and multiply it by 0 to get 0. And we look at our pattern, and our pattern is increasing by 2. So we end up with 2 and 4. So now this time I'm going to graph it on a graph like you'll have on your assignment. Okay, so the first one says from the origin, go left 2, down 4. Left 2, down 4. Put a dot. Okay, the next one says left 1, down 2. Put a dot. And then 0, 0 is the origin, so we place 1 on the origin. And then right 1, up 2. And then right 2, up 4. And again, it appears that they lie on a line. And the reason why they're lying on a line is because if we look back at our standard, we're representing linear relationships. Linear means line. Okay, so everything we do is going to be in the form of a line today. Okay, so to represent all the points that are on this line, I play connect the dots and add arrows on both ends. And that's what we do. So let's have you try one on your own. Pause the video and evaluate this expression for 3x minus 3 and graph it for me. Okay, let's see how you did. Now the first thing I would do is I'm going to change this subtraction to addition, next number to its opposite. Because you know that's just one thing I don't like to do. I don't like having minuses because I want to change it to prevent making careless mistakes. Okay, so now let's see what the evaluation will be. So in this one I've got 3 times negative 2 plus negative 3. So 3 times negative 2 gives me negative 6 plus negative 3 gives me negative 9. Okay, so then 3 times negative 1 plus negative 3. So 3 times negative 1 gives me negative 3. And negative 3 plus negative 3 gives me negative 6. So 3 times 0 plus negative 3. Well, 3 times 0 is 0. Plus negative 3 is negative 3. So what are we doing? Well, we're increasing by 3. So if I increase by 3 again, I get 0. And increase by 3 again, I get 3. So now we graph. Okay, so the first one says left 2, down 9. Put a dot. Next one, left 1, down 6. Put a dot. Next one, right or left none, down 3. Put a dot. Next one, right 1, but don't go up or down any. Just put it on the axis. And then right 2, up 3. Okay, so again, it appears that they lie on a line, so I connect the dots and extend out past in both directions. Okay, we got one more I want to look at before we get to our assignment. Okay, and this one right here. Now this one's very similar to one that we've done already, number 3 here, where we had 2x, but this one is negative 2x. So let's find out what will that negative do to our picture, to our graph. Okay, so we evaluate. So I've got negative 2 times negative 2, which gives me a positive 4. Negative 2 times negative 1 gives me a positive 2. Negative 2 times 0 gives me 0. So what is my pattern? Well, on this one, I'm decreasing by 2. So that means the next one will be a negative 2 and a negative 4. So if you look at your values on the previous problem that we did that was just positive 2x, you'll notice we've got negative 4, negative 2, 0, 2, and 4. The negative seemed to flip my values. Now, what does that look like in terms of the picture? Well, in the first one I did left 2, down 4, but this one I'm going to go left 2, up 4. Okay, and then left 1, up 2, and then back to the origin, and then right 1, down 2, and then right 2, down 4. So what appears to be happening? Well, what we have in our first one, we had a graph that we would say is going uphill because we always read a graph from left to right. So this one's going uphill as we are moving to the right on that graph. Okay, so this graph is increasing. Well, this graph, as I move from left to right, it is actually decreasing or going downhill. So that negative, what it does is it flips the graph and makes it go downhill instead of uphill. Right? And that's what we do whenever we're graphing these expressions. So what we're going to do on our assignment is I'm going to give you a series of t-charts where I need you to evaluate that expression and show me the graph. Okay? And the way we do that is we show our work, we create our y values, which create a set of coordinates, and then we put those coordinates on the graph. So until next time,